Question 17 from the heat topic. Two ice blocks of mass 20 grams each are placed in 500 grams of water at 40 degrees. What will be the final temperature of the mixture? Assume no heat is lost to the container or the surroundings. First thing, it's a mixture. So that means that the hot thing will lose energy and the cool thing will gain energy. So we can say safely that the energy lost has to equal the energy gained. We're also assuming no heat is lost to the container or the surroundings. So that means all the energy lost by the warm thing will be picked up by the cool thing. So this is the hotter thing, 40 degrees, and ice is 0 degrees. So what's going to lose energy? Well, this will be the water. This will be the energy gained by the ice. So, lost means minus, and because the water is going to go down in temperature, we use the MC TF take TI because there's a change in temperature here. Now the energy gained by the ice, well, two things are going to happen actually. First we need to melt the ice, so take it from solid water at 0 degrees to liquid water at 0 degrees, and then once it turns into water, the temperature will start to rise until it matches the same temperature as this water. So what's the energy, or Q, gained by ice? Well, it's plus ml. Okay, so that's what we need to, the energy required to melt the ice, and then it'll be water at that point, so MC TF take TI. Okay, because the water temperature, well, it was ice and now it's water, its temperature will start to rise. So let's go lost by the water. Take mass, which is 500 grams, that's 0.5 kilograms. The specific heat capacity of water, I'm pretty sure the table says 4,200. Yep, 4,200. TF is unknown. That's what the question's asking for, the final temperature. Take away the initial temperature of the water, which is 40 degrees. Equals the mass of the ice. Well, it was two ice blocks, 20 grams each. That's 40 grams in total, which is 0.04 kilos, times the latent heat for ice. So that's melting. It's turning from solid ice to liquid water. So that's this column, that's latent heat of fusion. So here's the latent heat of fusion for water, 3.34 by 10 to the 5. Plus the mass of the ice, well actually it's turned into water now, so the mass of the water that was ice before is still 40 grams. The specific heat of water, not ice, because it used to be ice, but now we've melted it, so it's the specific heat of water, which we found earlier, 4,200. The final temperature we don't know, but we know the initial temperature of the water that used to be ice is 0 degrees, because first it melts, it was ice at 0 degrees, then it melts to water at 0 degrees, and then the temperature starts to climb. So, what's the next step? We have TF here and TF there, so it's on the left and the right, so we can't solve it yet. We need to collect all the TFs onto one of the sides of the equation, either on the left or on the right. So first we need to simplify and expand out all the brackets. So let's simplify bits at a time. Let's do that bit. So that's negative 0.5 times 4,200, so that's negative 2,100. And then TF take 40. We can simplify this. It's 0.04. I'll do it on my calculator. 0.04 times 3.34 by 10 to the 5. That's 13,360. Then we can simplify this section. So 0.04 times 4,200 is 168. so plus 168, then TF take 0. Next step, we need to expand the brackets out to get these TFs out of the brackets so that we can do something with them. So we do negative 2100 times TF and negative 2100 times 40. So that will be negative 2100 TF, and then negative 2100 times negative 40 is positive 84,000. Next bit. 13,360 carries through, plus, we'll expand this, 168 times TF is 168 TF, and 168 times 0 is nothing. So technically you could have just gotten rid of that here and just said it's TF take 0 is TF. Next part, because we have TFs on the left and on the right side of this, the equation, here's the dividing point of the equation, the equal sign, we need to get rid of the TFs from one of the sides. So if we have 168 TFs here, let's take them all away. So take away 168 TF. Do the same thing over here. That means on the left hand side of the equation, this take away this is negative 2,268 TF plus 84,000 equals 13,360. Now it looks like a normal equation where we've got one unknown and some numbers to get rid of. So first we'll take away the 84,000, which gives us negative 2268 TF equals 13,360, take away 84,000, which gives you negative 70,640. Okay, I'll move all this up and get our last step. Now to finish off, we just divide both sides by negative 2268, because that will remove that number. Which gives us TF equals 31.1 degrees Celsius. Okay, that's it.